Hello everyone, we're back again with another integral problem. As you can see in the graph, we have three functions, f, g, and h. They are drawn in the coordinate plane as shown. It might look a bit complicated at first, but don't worry, it's actually not. Here's what the question says. In the Cartesian coordinate system, the functions f, g, and h are shown on the left. The shaded regions labeled a1, a2, and a3 have areas of 1, 3, and 9 square units respectively. We are asked to find the total of two different definite integrals. Let's start with the first integral. What does it say? From a to c, h of x minus g of x. Always remember this. The integral represents the area under the curve. Let's highlight the graph of h of x from a to c with a thick red line. Now look at g of x over the same interval. Since the expression inside the integral is h of x minus g of x, and g of x lies above h of x in this interval, this integral actually gives us the negative of the total area between the curves, which is the sum of a1 and a2. Now let's move on to the second integral, from b to d, f of x minus h of x. If we highlight the graphs of these functions between b and d, we can see that h of x is below and f of x is above. Since we're integrating f of x minus h of x, this gives a positive area, which is the sum of a2 plus a3. Now let's add the two integrals together. On one side, we have minus a2, and on the other side, we have plus a2, which cancel each other out. What remains is a3 minus a1. We're told that a3 equals 9, and a1 equals 1, so the result is 9 minus 1, which is 8. The correct answer is option B. It wasn't as hard as it looked, right? All right, see you in the next question.